It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about infinite limits, and this is the part 3 of my video. Let's now start with our evaluating of limit. Once you have their limit of 3 over x plus 1 as your x approaches negative 1. So all you have to do, if you try to look at that, we don't have any sign at the top of negative 1. So that means to say that we are going to evaluate from the left and right of our limits, by the way, of that function. So if you are going to also substitute this one, if you do the substitution or direct substitution here, you would notice that we've got 3 over x is with negative 1 plus 1. This would lead to a 3 over a 0. So that means to say that it could be 3 of the it could be one of the following choices. You've got there positive infinity, negative infinity, or a d and e as the limit answer for this. So let's now try to test out our negative, or not negative, but from the left hand limit. So let's try to test it out. And then we've got here limit of 3 over x plus 1 as your x approaches negative 1 coming from the left side. So since that is coming from the left side, and we know already that this would lead to a 0, that means to say once we do the substitution, if you try to look at our number line, if this is our negative 1, whatever is on the left side are going to be moving towards a negative direction or negative infinity. And next, after this one, we've got a negative 2 for this. So meaning if you are going to substitute a value there on x, we will be getting that one from the left side of negative 1. And that might be here. We have to choose the closest number on negative 1. So let's have our negative 1.1 might be. So if you've got there negative 1.1, you can also, by the way, choose negative 1.01, negative 1.001 in testing out. Anyways, we're just testing out the sign here of our denominator, whether that would lead to a positive or negative result. So substituting, this will be now 3 over our x there will be negative 1.1 plus 1. Now, this would lead to a 3 over negative 1.1 plus 1 is a negative 0.1. So see, we've got here a negative on the denominator. So that means to say that our limit of 3 over x plus 1 as your x approaches negative 1 coming from the left side is a negative infinity. So let's try to test out our right-hand limit. So we have limit of 3 over x plus 1 as your x approaches negative 1 coming from the right side. So we will be choosing, because this would lead to a 3 over 0 once we try to substitute x by negative 1. So we will be choosing a number on the right side of, or from the right side of negative 1. So if this is the position of negative 1, on the right side of that one is our 0. So your number here, which is closer to negative 1, might be our negative 0.9 or negative 0.99, negative 0.999. So anyway, so we're just testing out what will be our sign of our denominator here once we substitute that particular value. So this will be now 3 over x here is negative 0.9 plus 1. This will be equivalent to 3 over. This will be giving off a positive result. This will be with a 0.1. So that's positive. So this would simply mean that our limit of 3 over x plus 1 as your x approaches negative 1 coming from the right side is a positive infinity. Now, if you try to compare the limit from the left side and right side, they don't have the same limit. The other one is negative infinity, while the other one is a positive infinity. So that is why once you will be answering the limit of 3 or evaluating the limit of 3 over x plus 1 as your x approaches -1, the answer here is a D and E because they don't have the same limit from the left side and right side. So that's, of course, a limit does not exist. So let's now move on to the second one. So we've got limit of 3 plus 5y over 1 minus 2y as your y approaches 1 over 2 or 1/2 from the right side. So if we try to do the substitution here, well, of course, you need to really check whether your denominator here becomes a 0 and the numerator is not a 0, because once you've got a 0, 0, that means to say we can do something on, or we may do something on our function. We may manipulate our function if that will be the case. So that is why we need also to check whether our numerator is a 0 or not. So trying substitution here, we've got 3 plus 5 times 1/2 because our y is 1/2 over 1 minus 2, our y is 1/2. And then checking whether that would lead to a 0, 0 or a numerator which is not 0 and the denominator which is 0. So let's try to simplify. This is now 3 plus 5 times 1/2, that is 5 over 2 over 1 minus 2 times 1/2, that is 2 over 2 because 2 times 1 is 2, and then over 2, that is equal to 1. So if you try to look at the numerator, that will not lead to a 0. So why bother doing the simplifying of that one? So we'll just leave it as it is. Or you can have it as 3 and 5/2 over a 0. So that means to say that this will be leading to either a positive infinity or a negative infinity. So we will be now redoing this one. So we've got here limit of 3 plus 5y over 1 minus 2y as your y approaches 1/2 coming from the right side. So if you try to view your number line, if this is our 0, this is our 1, 1/2 is in between. So if you try to pick on a number which is closer than 1/2 or closer to 1/2 coming from the right side, you may go over to converting this one into a decimal, or this could be a 0.5, so that we can really figure out as to what will be our closest value to our 0.5 coming from the right side. So I may pick on substituting our y value with a 0.6, or you can have a 0.55. That's really fine, as long as you're picking on a number which is close to that approach value, which is 1/2 or the 0.5. Okay, so I'll be picking on again a 0.6. So we have here at the top, since we don't have a problem at the top, so we always have to use the actual value here. So we've got 3 plus 5 times a 1/2. And then at the bottom part, because this would lead to a 0, so that is why we're trying to check whether it's going to be giving us a positive at the bottom part or a negative at the bottom part, so that we can determine later on as to what will be our limit here, whether it's positive infinity or a negative infinity. So we've got 1 minus 2, and then the y there, instead of 1/2, we will be substituting a 0.6, or if you try to convert a 0.6 to our fraction, this would lead to a 6 over 10 because we've got tens here, tens placed on the decimal part. So reducing that one, this would lead to a division with 2 at the top, and so with here. So that would lead to a 3/5. So that will be our equivalent value on the fraction. But anyways, I'll be using the decimal here. So that means to say that once we try to simplify this one, it's really fine if you stop here and you've already determined whether that will be a positive or negative by simply looking at it. You may stop in there as long as you know already the sign. But if you don't, then you can continue this one. So we can have here 3 plus 5 over 2 over 1 minus 2 2 times 0.6, that is 1.2. And then if you want to continue more because you haven't seen any sign at all, or you cannot figure out the sign here, the resulting sign here, but we know already that the top is a positive. But for the bottom part, we don't know. You might know, or some others might not know. But for the sake of the discussion here, let me just continue this one so that you can really see as to how to distinguish whether it's going to be positive or negative infinity. So 3 plus 5 halves, you can actually have it as 3 and 5 halves if you want to. Or that could be simplified further, but we really don't care about that one. What we wanted to care here is the sign. So we've got a positive here. And then at the bottom part, once you subtract 1 with 1.2, that will be equal to a negative 0.2. So see, this is positive on the numerator, negative on the denominator part. So that means to say we've got a positive over negative. That will be equivalent to a negative infinity. So the limit of your 3 plus 5y over 1 minus 2y as your y approaches 1/2 coming from the right side is a negative infinity. Next, we move on to limit of 2 over s squared minus 2 to the power of 4 as our s is approaching our square root of 2. So since we don't have a sign at the top of square root of 2, what we are going to do is to check on the two limits coming from the left side and right side. So we'll start with identifying first whether that will lead to a limit with a non-problematic limit, like a value, whether this would lead to a value, because if this would lead to a value, that means to say that we don't have a problem at all. But if this will not, then we have to do something on that. So if you try to substitute this, we've got 2 over s squared is, our s is square root of 2, and then we square that one, and then we have minus 2, and then we raise that to the power of 4. So this is now 2 over, this will be canceled, so we've got a 2 minus 2. This would lead to a 0, so we've got a 2 over 0 raised to the power of 4, that is a 0. So that is why we have to check our left and right hand limit. And then there will be 3 possibilities here, whether we've got a positive infinity, a negative infinity, or a DNE. So let's try to check that one out. So starting off with the limit of your 2 over s squared minus 2 raised to the power of 4 as your s approaches square root of 2, coming from the left side. So if you wanted to know what is the closest value of square root of 2 there, we may convert our square root of 2 into decimal number. That I think that is the easiest way. This is 1.4142, or we can have it as 1.41. By simply having that one, we would know what is the closest value of that particular number coming from the left side and right side. So for this example here, we are going to look for a number which is closest to our square root of 2 coming from the left side. So since square root of 2 is 1.41, what is on the left side there is gonna be a 0. So coming from the left side, we may have a 1.4 in here. I think that is the closest one on our square root of 2. We'll be considering a 1.4. So simplifying or substituting our s there with 1.4, this is now 2 over 1.4 squared minus 2 raised to the power of 4. Simplifying that, this is now 2 over 1.4 squared. 1.4 squared is simply 1, oopsie, for a while. 1.4 squared, that will be 1.96. So we have 1.96 minus 2 raised to the power of 4. Simplifying that one, if you cannot view that as to whatever will be the sign here, but take note, our exponent there is even. So automatically, whatever is inside there is gonna be a positive because your exponent is an even number. So for the sake of the discussion again, or for the sake of clarification, let me just simplify this one further. So we've got 2 at the top, which is a positive, and then we've got 1.96 minus 2, which is a negative, and 0.04, and then we raise that one to the power of 4. This would really create a positive result at the denominator. Even though you wanted to really try it out, you can clearly see that that would lead to a positive 0.000000256. So let me write that one. So we've got 2 over 0.000000256. Making sure that that is 2, 4, 5 zeros. So if you try to look at this, this is positive, this is positive. So this would lead to a positive infinity result once you say limit of 2 over s squared minus 2 raised to the power of 4 as your s approaches square root of 2 coming from the left side. So let us try to find out our limit of 2 over s squared minus 2 raised to the power of 4 as your s approaches square root of 2 coming from the right side. So again, if you try to look over at the number line here, we can simply have our square root of 2 as 1.41. And then from the right side, we may take on 1.42 if you want to, but let me just have the 1.5. So here, let us try to substitute the 1.5 that I was talking about a while ago. So we've got there 2 over 1.5 squared minus 2 raised to the power of 4. And then we try to simplify that one further. And if you know the shortcut of that one, because your exponent at the bottom part is even, automatically that will become a positive, or the result of the denominator part will become a positive. So anyways, let me just show you that one. So 1.5 being squared, that's equivalent to 2.25 minus 2 raised to the power of 4. This is 2 over 2.25 minus 2, that's 0.25, that's positive. And then we raise that to the power of 4. So the result there is going to be 2 over 0.00390625. So see, this is positive. This is positive. So we have here a positive infinity. Now, since our limit from the left side and right side are the same, so automatically once we say limit of our, for a while, limit of our 2 over s squared minus 2 raised to the power of 4 as your s approaches square root of 2, that will be a positive infinity. We have the limit of 1 minus t over the square root of t minus 4 as your t approaches 4 coming from the right side. So if we try to simply substitute that one for checking purposes, whether whatever happens here after substitution, we would know this will become a 1 minus our t there is 4 over the square root of 4 minus 4. So this will be equal to 1 minus 4 is a negative 3 over square root of 0. That is a negative 3 over a 0. So that means to say that we are going to check what will happen if we are going to get a number coming from the right side, which is close to the number 4 there. And then let's have here limit of 1 minus t over the square root of t minus 4 as your t approaches 4 coming from the right side. So if you have here a number line, this is 4. From the right side, we have the number 5 here. The number which is close to 4 here is 4.1. So we may use that one in evaluating our limit here. So this is now equal to, at the top, we don't have a problem really on that one. So we just have to retain it as 1 minus our 4. And then we have over the square root of t there will be replaced with a 4.1 minus 4. This is equal to 1 minus 4. That will be a negative 3 over 4.1 minus 4. That is the square root of 0.1. Since this is a square root, it will never happen that we will have a negative result for that one. So that means to say that this is negative over a positive value. So since that's negative over positive, that will lead to a negative result. So we've got a negative infinity for that one as our answer for the limit of 1 minus t over the square root of t minus 4 as your t approaches 4 coming from the right side. Let us now move to the limit of 4 plus r over r plus 1 times 10 over r squared minus 25 as your r approaches negative 25 coming from the right side. So we are going to test out whether this would lead to a negative result. I mean, not a negative result, but a number over a 0 result. So let's try to have that one. So we have 4 plus r. So we have 4 plus negative 25. Our r here is negative 25. And then we've got r, which is negative 25 as well. And then we have plus 1 times 10 over r here, which is negative 25 squared. And then we have minus 25. So this will be equal to 4 plus negative 25. That will be negative 21 over negative 25 plus 1. That is negative 24 times 10 over negative 25. Once you square that one, that will be equal to 625. And then minus 25. This is now equal to, we can simplify this one further. This is negative divided by negative. That will be a positive. Common factor here is 7. No. The common factor here is a 3. So we will be dividing this one by 3. And so with that one, so our result here is a 7. So this is where the 7 goes. Okay, 7 over 24 divided by 3, that will be an 8. And then we have times 10 over 600. So 10 over 600, we have to cancel out the 0 in there because zeros are common. That's how you divide multiples of 10. So this is going to be 7 over 8 times 1 over 60. And then we try to simplify this. This is 7 over 8 times 60. That's 480. So that will be our limit. Notice we don't have a 0 here on the denominator. And we don't have anything wrong with the numerator. So that means this is our limit of our function. So this is the limit of 4 plus r over r plus 1 times 10 over r squared minus 25 as your r approaches negative 25 coming from the left side. We have limit of 5 over x minus 2 over 3x squared as your x approaches 0 coming from the right side. So let's try to test it out. We've got 5 over x will be a 0 minus 2 over 3. Our x is a 0 and then squared. This would lead to a 5 over 0 minus our 2 over 0. So since both of them has a number over 0 pattern, once we do the substitution of each, that would simply mean that we have to check out what will be the limit if we choose a number from the right side of 0 that is very close to 0. So let's have that one here. So limit of 5 over x minus 2 over 3x squared as your x approaches 0 coming from the right side. So since this is subtraction or this is difference of function, we can actually write it into limit of 5 over x as your x approaches 0 coming from the right side minus a limit of 2 over 3x squared as your x approaches a 0 coming from the right side. And then we try to get the limit of h. So we have here, if this will be our 0 on the number line, what is on the right side is 1. So that means to say that this 1, which is very close to 0, might be a 0.1. So we will be replacing x here with 0.1 for this because that will lead to a 5 over 0. So that means we have 5 over a 0.1. And then minus, we have here a 2 over 3 times a 0.1 squared. Now notice here that we have here a positive. That means to say this is positive infinity minus a positive and a positive, that will be a positive infinity. Now, without this thing that you are going to do, you can actually make use of the limit theorem, the first limit theorem that we've known, that once you've got there a limit of 1 over x to the power of r as your x approaches a 0 coming from either left side or right side, then automatic will be having that one as if you've got a positive here, automatically that's a positive infinity regardless of whatever is r in here. And then if you've got a limit of 1 over x to the power of r as your x approaches 0 coming from the left side, this would matter. You will have a positive or a negative result in there dependent on the type of r you've got, whether it's even or odd. So if you've got even r here, that means to say that you will have a positive infinity, but if you've got an odd r here, you will have a negative infinity. So you can use that one. Now, since this one here is a positive or coming from the right side, automatically everything here will become a positive infinity. The other function here, you've got also a coming from the right side here. So automatic, whatever is the exponent of your x in there, that will lead to a positive infinity. Now, simplifying this, positive infinity minus positive infinity, they have the same sign. That would not mean that that is a 0 because this might be different in number. The two infinity there might be different in number, but once you say infinity, that represent a very huge number. So that doesn't mean that this will give off a 0 as an answer, but this will become a DNE. The limit here does not exist. Now, this same goes with when you are saying negative infinity plus, minus negative infinity. That will be the same thing. Okay, so let's now go for another example. The next example is the limit 1 over 2 minus x plus 4 over 4 minus x squared as your x approaches to coming from the left side. So if you try to check it out, whether this would lead to a 0 over 0, you may skip on the process because you wanted to check whether it's going to be a 0 over 0. So 1 over 2 minus 2 and then plus 4 over 4 minus 2 squared. This would lead to a 1 over 0 plus 4 over 0. So we are going to apply our infinite limit here. So we've got limit of 1 over 2 minus x plus 4 over 4 minus x squared as your x approaches 2 coming from the left side. So if you've got there 2, on the left side we've got 1. So getting a value which is close to 2 from the left side would mean this is a 1.9. So we may substitute each. So let's try to expand this. This is now limit of 1 over 2 minus x as your x approaches to coming from the left side, plus limit of your 4 over 4 minus x squared as your x approaches to coming from the left side. So this is now equal to, once we try to plug in 1.9, so we have 1 over 2 minus 1.9. And then plus, we have 4 over 4 minus 1.9 squared. So simply looking at this, if you can determine right away what will be the sign at the bottom part, then go ahead. But if not, you may do the computation here with 2 minus 1.9. That would lead to a 0.1. So 1 over 0.1. This will give off a positive infinity. And then this one here, plus 4 over 4 minus 1.9 squared. That will be equivalent to 3.61. So again, if you spot right away what will be the sign here at the bottom part, then you may do so. Go directly as the result or whatever is the result of that one. So we've got there 4 minus 3.61. That is 0.39. This is positive, positive. So we've got a positive result here. So positive infinity plus positive infinity. This is equivalent to a positive infinity. So the limit of 1 over 2 minus x plus 4 over 4 minus x squared as your x approaches to coming from the left side is a positive infinity. So that is how you are going to evaluate limits using or with infinite limits. So once again, this is your teacher Jenny. Hope you are going to practice this one. This is a lot easier as compared to the different evaluating of limits. So please practice that one.